Hello everyone, welcome to the second part of the video tutorial series, Learning Pandas from Zero. My name is Xingqi Leung, and in this tutorial I will be your guide in Pandas. Today we will explore together how to make our first data frame from various types of source data. So first of all, when we want to process a table, why do we need a data frame instead of a two-dimensional list or an array? The answer is Pandas stores the data of a table as a data frame object, and if we want to make use of the efficient algorithms in Pandas, data frame is the starting point. Here I show you the simplest way to create an empty data frame. First, we import Pandas. I usually name it as PD to represent this library. Then we can create a data frame by simply typing pd.dataframe. Notice that in the keyword data frame, D and F are in capital letter. Then when we check the type of this object, bingo, it is the Pandas data frame. The previous slide shows how to build an empty data frame, but most of the time we do not need an empty data frame, but a data frame which contains the data we want to process. What should we do? In Pandas, we can form a data frame from multiple types of data, including a dictionary, a list, a CSV file, and an Excel file. In this video tutorial, we will focus on the first three as we will be using these three approaches very often. Now let us consider the case. I want to process this table in Python. What should I do? This is a very simple table, but we will do a lot of variations with it in this tutorial to explore different possibilities in Pandas. We can imagine this table is some fruit survey of different interviewed persons. There are simply two entries with names and their corresponding amount of fruit they have. If you are an Excel user, then very likely you will make a table like the screenshot I show on the slide. You enter the data one by one in each box. Then how about Pandas? When we create a data frame, we use the same command pandas.dataframe. Then in the argument, we pass the table data we want to convert. When we declare the object of the data frame class, there are optional arguments which can be chosen to best represent your original table. This includes, for example, the name of each index and columns. We will go through some of the useful ones later. The simplest one we can do is by passing the table data. Then the question becomes, what kind of data is necessary? Here let us use a dictionary as an example. If we pass a dictionary to a data frame, for each entry the key corresponds to the name of the column, and the value contains a list which stores all the data for that column. For example, if we describe the column for apple, we have the key as apple and the value to be a list which consists of 2 and 3. Then let us look at how the code can be done. We import the Pandas assuming this is the first time you use the package in the Jupyter Notebook. Then we build a dictionary which contains the table data column by column. Of course, in general, for a very large table, this approach is inefficient. But for demonstration purpose, let's input the data accordingly. Then we can convert the dictionary to a data frame by using the command I just mentioned. If we print the data frame, here is your first data frame which looks very similar to the table above. Notice that because we do not pass any information about the index, Pandas by default assign numeric 0, 1, 2, and so on to each row as the index. Then let's take a look when we pass a list instead of a dictionary to the data frame. In that case, instead of a column, we store the data in a row as an element of the list. For example, to contain the first row, we use a list and store both the index Mary and all the data on the same row, namely 2 and 5. The code is almost identical to the version using dictionary, but you may wonder, where do we pass the name of the columns? Let us examine the code to find the answer. Again, we will first import the Pandas library and then create a list that contains the table data. But this time, we define a list that contains all the column names. In this example, we have name, apple, and orange. And when we declare the data frame, beside the list of data, we also pass the list of column names. And the final table will be identical to what we see above and identical to the previous line. What will we have if we do not pass the column names? Let us take a look at this example. The code is almost identical except when we declare the data frame. The list column names is not passed. If you need some time to digest the code, feel free to pause the video. Here we show the results directly. We find that as a result, the data frame does not contain any information about which name corresponds to each column. When we print the data frame, we find that now all the column name becomes numeral, 0, 1, 2, and so on, just like the rows. When the column names can be set in this way, you may wonder if there is such a flexibility applies to the index. The answer is yes. In this code example, let's go through the procedure. Again, we import Pandas and set our list to store the table data. Then we define the column and index names into separate lists, namely column underscore names and index underscore names. While we declare the data frame object, we pass both lists into it. And then we can see that now the table has the index MO1 and MO2 instead of 0 and 1. This will be useful if the index is one of the identifiers of the entries. Now, finally, it is your turn. If we want to create a table similar to the one I show on the top right corner, do you know how to do it? For practice purpose, try different ways to pass the data. And if you need time to code, I encourage you to pause the video and work out on your own a solution first, and see if you have mastered the first step. Here is my solution. We will first import the library and set up the dictionary which contains the column names and data. And then we define the index name in a list. Then we create the data frame by passing the data and index name. Once we print the data frame, we should get the output from the Jupyter Notebook that looks like the sample on the top right corner. The last part we want to introduce is to pass a CSV file into a data frame. A CSV file is the short form for comma separated value file. On the right hand side, we showed one representation of the table on the left in the CSV form. Notice that in this file we do not include any space unless the space is a part of the string we want to store. Once we prepare this file, we can use the command read CSV to read the CSV file and then convert the file into a data frame. For clarity, I defined the file name in a separate variable, but you can also directly write the file name as a string and pass it as the argument. When we output the data, we obtain identical result again. Hooray! But notice that this method automatically treats the first row as the column names. If your CSV file does not contain any column names, we need to set the optional argument accordingly. Now we briefly take a look at different options available in the method CSV. The first one is header. By passing some integer, in this example 1, Pandas will use that particular row as the header for the column names. But notice that the data before the header will be ignored. The second option we want to introduce is the index code argument. If your file contains a column which stores the index of all entries, you should set this as the number of that column. In this example, we will use the column 2, that is, the third column counting from the leftmost one, as the index of all entries. Let us do our final exercise before we end this tutorial. Assume you have a colleague who gave you the above table to process. Let us build up our own data frame to store the table. This time, let's try both ways. Use a dictionary or a list and a CSV file to store the data, and see if you can correctly convert the data to the table like the one we show here. Again, feel free to pause the video to give yourself some time to finish the practice. If you have a code something like this on the right hand side of the slide, then congratulations. You mastered how to build a data frame from multiple types of data today. So that is the end of our second tutorial in the series. And once again, thank you for watching this video. I hope to see you again in the next tutorial. We will learn how to call the elements inside a data frame. Again, practice makes perfect. I will encourage you to also read my open source ebook on my GitHub repository to do some of the related exercise to strengthen your skills. I hope you have enjoyed the tutorial today. See you.